Hello, ladies and gentlemen. Today we're going to be playing around with the physics constraint. So what that is, it's basically like an object that fits in with the actor that lets you constrain an object that's simulating physics in certain interesting ways, whether it's a single point and it allows twist, or whether it's a hinged door, or something that just wants to be moved back and forth in a linear fashion. There's a lot of different things that you can do with this, and it's very interesting. It's also a little complex, but we'll get to that. So what I'm going to do is, just to start with, we're going to make a cube. Actually, we'll start with the door idea because that's probably the simplest to start off with. So what we're going to do, add our little cube, and we're going to make it smaller in one direction, and of course bigger in another. So just float that all the way to the top, so it's, there you go, it's sitting on the floor. Alright, so we're going to do the physics constraint, which is there, is basically just this little pseudo object. It doesn't have anything, there's no mesh associated with it or anything like that. It's literally just this object thing that sits in the actor. And what we're going to do is we're going to put it there in the middle on the side. So this will hinge based on that. So that out. Now we will need to enable the physics on the mesh. And that's somewhere in here. There it is, simulate physics. Now you don't really need to touch too much else, but what I am going to do is I'm going to give it a different texture just so we can see it a bit better. It's a bit ugly. Here we go. Go with oak. That's still ugly, but it'll do. So we're going to go into first person map. Now we can throw this on the floor and it's not going to do a terrible lot, especially if we just run into it. And it's, yeah, it's got a quite nice little sheeny look to it. So that's our door so far. So what we want to do is we want to go in there and we want to constrain it, going off the physics constraint. We're going to select the physics constraint. Now, a couple of things we've got to do, aside from hitting stop. We need to tell the physics constraint what we're actually constraining. And that's where this bit here comes in. Under constraint, you want component name. And what you want to do is you want to type in the name of the static mesh, cube in our case. And what this will do is it just tells it what mesh to use. Now moving forward, going down, we've got these two bits here, which are the interesting ones. Well, actually, there's a few interesting ones. Angular motor, angular limits, linear limits. So we've got swing motion 1 under, we'll just ignore these for now because we're dealing with something that's angular, so something that rotates. So you've got swing motion 1, swing motion 2, twist motion. Now, twist is literally as you imagine it, so you want to try and... I'll just show you. Everything's free at the moment, so that's sort of like the twist. See how it sort of pivots off that one little bit there? Off the corner there, so it goes wherever. So if we lock that, go back to this. Behaves a little differently, not by much. So what we want to do is we want to lock this one, I believe, and leave that to, I think, limited memory. It's sort of like a lot of screwing around and sort of testing it out. Some of it's quite fiddly. But there's our swinging door setup. And that's only moving the 45 degrees. So it's hard to tell, but yeah, these two bottom ones are locked. That one's limited. So if we just change that a little bit, you'll see the difference. So now it hinges in the other direction, which isn't bad. I mean, there's things you can do with that. You know, a fair bit of fun with that. But we want it to be the other way because we want a door that works. Let's turn that off. Okay, so that's the angular limit. That gives us the door, and we might just change that to 90 because we want it to be more of a door. See how it moves when you walk into it? So that's the limit there. The gun's actually quite useful for this. So we can knock it, and you go 90 degrees from the 0 point. So how it... That's what it sort of considers. It's 0. Well, close enough anyway. So you get the point. Alright, so what if we want this to sort of go back to its position? Well, we have the angular motor drive, or angular drive mode. So what this does is it goes, oh, it's not on 0. Oh, we want to try and push it back. And you've got a few little options here, which are quite interesting. A lot of this, from this point, is a lot of fiddling. So you've got to sort of fiddle and find out what the best settings are for the situation you're using it in. And yeah, it can be a little time consuming. But in our case, since we have this severe alert between the current orientation velocity and the target orientation. No, this will not work if any of the angular constraints are set to locked. Well, we've got, yeah, they're locked. So what we want is twist and swing. Now, we want the drive, the swing drive. So we want to select that. Target orientation, 0, 0, 0. So we want it to go back to where it was originally. So the angle that it's at when you place it in the world. It's the easiest way to do it. You can set these to different values. Now, the strength is the fun one. And on 50, I don't think you actually see very much. It doesn't actually go very fast, so at all. No, it still moves back a little bit. Very little in that case. And that's, yeah. That's because there's like the closer he gets to the target, the less force there is. So, yeah. So there's a few interesting little tricks you can do. One of them is when you're placing one of these objects down, what you want to do is you actually want to, don't put it straight on the ground. What you do instead is you go to its location, you type in 0.5. And this will actually make a massive difference because the bottom of it is no longer there's no longer a physics interaction going on between the floor and the object. So if we shoot that, you see there's a massive difference in what it was doing before, and that'll sit there and it'll just flop back and forth until it hits the 0 point, and that's because it's got a maximum strength of 50. I don't know whether that sort of comes down to 50 kilos, 50 grams, or 50 kilos, or whatever in the world. But yeah, so there you go. It stopped. So push it, and there you go. So that's something like a saloon door type arrangement. So yeah, that's where it can get fun there. So yeah, so what you can do we can make that better. What we can do is we can go into the actor there. We can go to this strength value. Let's just put it to 150. Compile and save. Let's just see what it does. It'll make it go quicker. So that. One of the things with this is that the sooner you have it getting back to its resting stage, the better. You don't really want these things constantly going, especially if you've got a few of them going in the game. So if you ever end up with, you want to try and avoid those situations where you got physics objects that are sitting there vibrating away, because it's not being solved, it's just being stuck in a loop, and it can really kill the performance. You see that sort of thing in that game, the Hydroneer. When that guy Josh from Let's Game It Out is playing, and he's got all these physics objects, so the little gem things, or everything all over the ground, and stuff's vibrating around, and it's killing his frame rate because, yeah, the physics engine's working overtime to make it work. So it's, yeah, so that's pretty good. That's not bad, really. So you can walk through it. You can even do the double door thing too, which isn't terribly difficult to do. So what you do is you get to the right position, of course. You just hit copy, paste. You can actually see on the actor itself too where the constraint is. So there, on that one it's there, on that one it's there. What we just want to do though, so we just want to flip this one around. So we're just going to flick that around. We just want to flip that around like that. And then what we want to do is we want to move it up against it. Now this isn't going to work out too well. Well, sometimes it does, sometimes it doesn't. But now, realistically, doors don't look like that. They don't meet perfectly in the middle. And what you would really do is just you put a small gap in between. So, for example, 0.5. Because the other thing is too, what's going on there is like a physics collision going on, because you've got two bits operating in the same space. So now you can see that gap. It's going to be a little better, and it's not going to. When it comes to a stop, the physics thing's gonna stop solving because there's nothing left to solve. So yeah, you've got that. So that's an interesting little double door, and you can use that in a few different places. It's not bad. There's not much of it's not really that taxing, as you can see on the graph. We're still getting about 100 frames a second. So alright, so we've done doors. So what about this linear thing that we see in there? So we've got some linear stuff going on. We've got linear limits. We've got a linear motor set up. This works exactly the same way as the angular motor one, just slightly simpler. Again, a lot of this stuff you will just have to fiddle with in some cases to get to the right settings. It's not the best, but it works. So what we're going to do is we're just going to create an actor, and we're going to call it cube push, because that's what we want to do to it. And we're just going to create a cube in it for something to be there, and we're going to hit the physics constraint, which is going to be off the cube. And we just want to lift this cube up so that it's off the ground, and done. Save and compile. So what we'll do is we will drag said cube into the world, and we're going to drop it there. Now, under this, we want to simulate physics. Good. Let's leave that at that. So now we need to go in here, into the physics constraint. And again, we need to set the component name to cube, because that's what we're pushing around. So what we want to do is we want to make it just move on one axis within a certain amount of movement. So we go down to linear limits. Now we can have either free, or we can have limited along one axis for the x-axis, and the same with the y and the z. Value of 100, so that we can see it on the grid, how much it moves. So basically that means it'll move into the next grid area. The next thing, we don't want it spinning on us at all, so what we're going to do is we're going to lock all of these. And that should be it. It should actually work now as a physics object that we can push in some direction. There we go. The mass must be too high for us to be able to push on it. But generally, there you go. That's what it's doing. Pretty simple. Now, we can have it go back to one spot. So we've limited it to that 100. What we want to do is we want to go to here, position target, and just leave it at that. Now it's not actually going to come back to it, not actually going to go back to its position. This actually may actually help with the pushing part. We're just going to set this at 0.5 above the ground, and this will help with the collision stuff. So there we go. We can push it. See what's going on there? So how it's... So again, you can see on the graph there's not a lot of load on this thing, not really. I mean, if we put like 20 of these things in here, it'll probably be an issue. I mean, how bad could it possibly be? So let's just shoot them all. So there's not really much of a frame rate drop at all. Mind you, this is a fairly high-end system too. You might see something on lower-end systems, but that's how the linear part works. So it's pretty interesting. I mean, there's plenty of applications for it. You can also do it in the z-axis direction as well. So you can do like a platform that you can jump on, and it will just bob up and down until it finds the equilibrium between the person standing on top of it and where it wants to go. So there's that. It could be useful to bring it into a ship, but so when you stand on it, the whole thing sort of tilts over to some degree. That's doable. I'm sure that's been done in a game before. So yeah, that's that part. So else is there as far as the physics constraint stuff goes? I think that's pretty much it. That's the general gist of how it works. You've got target velocity that you can set to higher values as well. But again, a lot of this stuff, just make a project like this and just experiment with it to get a feel for what you actually need in whatever object you're going to make, or whatever game you're going to make. So